Okay, welcome back to another explainer. I'm your senior construction consultant here at the Info Engineer, and today we're diagnosing a massive problem. I'm talking about the kind of problem that literally costs homeowners and contractors thousands of dollars in rework and wasted materials every single year. Yep, we are diving into wall plaster cracking and exactly how you can prevent it.
I mean, we've all been there, right? Nothing, and I mean nothing, is more frustrating than finishing a brand new wall, getting it painted to absolute perfection, and then almost immediately seeing these fine spiderweb cracks spreading all over the surface. It's totally a nightmare scenario. You've put in the time, the labor, the cash, and then bam! Crazing and map cracking just completely ruin the finish.
So, you absolutely have to internalize this fundamental truth. Cracks aren't just aesthetic. They're actually signs of structural or material failure. Whether you're looking at a tiny hairline crack or a massive structural gap, that wall is practically screaming at you, trying to tell a story about what went wrong beneath the surface. And honestly, it usually comes down to a few very specific, highly preventable errors. All right, let's jump right into section 1, the root causes, or the why behind the failure. Whenever I investigate a failed wall, there are exactly 3 root causes you should always check first. Number 1 is shrinkage from excess water or cement. Number 2 is poor substrate preparation, specifically the lack of a proper key. And number 3 is curing failure, like skipping that crucial 7-day process. Let's break these down so you know exactly what to look out for. So, cause number 1, shrinkage stress. You see this happen a lot when an amateur adds way too much water or cement to the mix. Sure, it might make the mortar feel buttery and super easy to trowel on, but as that excess water evaporates, it creates massive internal stresses. The plaster is literally pulling itself apart as it dries and contracts, leaving behind those ugly spiderweb cracks. Moving on to cause number 2, substrate preparation. Guys, the difference between a pro and a novice here is night and day. On the left, you've got a properly cleaned, grooved surface. Some folks call this hacking or providing a key. That texture locks the plaster in, creating a solid mechanical bond. But on the right, a dusty, totally smooth wall. Plastering over dust or oil guarantees immediate debonding. If you tap it, it's going to sound hollow, and eventually it's just going to fall right off. And finally, cause number 3, the curing failure. Honestly, this is where so many contractors try to cut corners just to save a little time. Skipping the mandatory 7-day moisture curing process leaves your base coat absolutely starved for water. It turns weak, powdery, and incredibly prone to cracking. Remember, plaster doesn't just dry, it has to cure, and curing requires sustained moisture. Okay, let's move on to section 2, the engineering standard, or the how to fix it. This right here is your golden rule. For standard interior residential walls, you want a 1-to-4 ratio. That's 1 part Portland cement to 4 parts clean, fine, washed river sand. Please do not use random construction sand that's full of clay or dirt, or you're going to completely ruin this ratio. 1-to-4 gives you that perfect sweet spot, tactile strength to resist bumps, and enough flexibility to resist cracking. Now, let's look at how this standard shifts depending on the application. While 1-to-4 or 1-to-5 is your daily workhorse for standard walls, the mix changes based on load and exposure. You'd use a richer 1-to-3 mix for high-strength ceilings because, well, you need maximum grip to fight gravity. On the flip side, you'd only drop down to a leaner 1-to-6 ratio for economical interior walls where the weather exposure is absolute 0. Which brings us to section 3, the moisture logic, or why water is actually the enemy. We really need to clear up the difference between hydration and drying because they are not the same thing at all. Hydration is a slow chemical reaction where the cement particles bind together. It absolutely requires moisture to cure and harden properly. Drying, on the other hand, is the rapid, damaging loss of water to the atmosphere, which causes violent shrinkage. We want slow chemical hydration. We definitely do not want rapid drying. Then that leads us to a massive on-site mistake. Adding excessive water just to make the mortar easily workable on the trowel is a fatal error. It literally dilutes the cement paste, pushes the particles apart, and guarantees a weak, porous finish that is going to crack the second that water evaporates. Listen, plaster should flow, not pour. You have to keep your water ratio strictly controlled. Next up, section 4, the secret step. This is all about essential substrate prep. All right, here is the exact non-negotiable sequence. Step 1, clean the masonry of any dust or oils. Step 2, and this is the real secret here, dampen the wall surface thoroughly before you apply any mortar. Why? Because if you slap fresh, wet plaster onto a bone-dry brick wall, those bricks are going to act like giant sponges. They'll instantly suck the moisture right out of your fresh plaster, completely ruining that hydration process we just talked about. And finally, step 3, apply the mortar uniformly. Seriously, never skip step 2.
Let's hit section 5, an actionable pro tip for reinforcing your mix. Here's a pro tip you can literally use on site today. Start reinforcing your mix, stirring 3mm synthetic polypropylene fibers right into your plaster mix, or embedding a fiberglass mesh at high stress areas, like right where a brick wall meets a concrete column, is an absolute game changer. These materials actively absorb the tension created by thermal expansion. They act like thousands of tiny microscopic shock absorbers, completely preventing those nasty structural cracks. So what's the big takeaway here? Follow these engineering standards to the letter. Get that 1:4 ratio right, never cut corners on your 7-day curing process, always pre-dampen your walls, and stop wasting your hard-earned money on rework. If you found this helpful, subscribe to The Info Engineer for more construction precision. But before we wrap up, I want you to ask yourself something. If water is simultaneously the creator and the absolute destroyer of your mortar strength, how well are you actually controlling the climate on your job sites right now? Think about that for a bit. Catch you in the next explainer.